Hello everyone, I am audible.
Yes, sir. Yes, sir.
Anyone can respond. Am I audible?
Yes, sir.
Fine. Okay. So good evening to all of you. Uh, Today we'll start with the MCH-4, your course MCH-4, that is syllabus we have to start. So let me to share with the that is first chapter, and this is the thing. Okay. This is the introduction to the electrochemical analytic introduction to the electroanalytical methods. So actually, this particular chapter is belongs to the electrochemistry. As you have learned so many things in your past record, that is in your past degrees. So this is, if we come to that point, that is electrochemistry, you are well configured with the term electrochemistry. So this is the chapter which is connected with that one. You have learned so many things in there over there, but right now what we read, that is the practical base, right? So this is the complete things you have to read here over. So on the basis of that electrochemistry, how it developed, what is the what is the related facts are associated with this electrochemistry, and how it is means see that you come to the very particular sense. We all are well configured with the battery, right? Or it may be dry cell, maybe liquid cell, whatever may be battery. You are using several battery in your daily life, like your that is your remote battery or car battery or motorcycle battery, whatever may be. So that battery is if you say, this is actually, this is not only one example. Several types of batteries are there. So in your watch, what batteries you are using, that is not equal to the that battery which you are using in the remote, and that is not equal, that mechanism, what I'm going to say, that mechanism part is not equal what are you using in case of your that is car and a motorcycle, whatever may be, right? So different, but yes, another thing is that is batteries used in case of your mobile charger, mobile batteries. So mechanism is different, but overall things are same. That working procedure is something different, but overall procedure, it is, we have to understand that what exactly happened. So I am giving one example, starting with the example where you can use this electrochemistry, that is analytical methods. So this is electroanalytical methods, means you have to very particularly, you have to understand that how the mechanism is going on, what is the application part, how will do. If I'm working in an industry that where that usually these batteries are means creating or something like mobile batteries are developing or manufacturing, so what type of mechanism I have to use? If I'm an automobile engineer, I'm working in the automobile sector, so the battery is used, what type of battery we have to use there, over what type of mechanism. So this is the, actually this is the, honestly if you say, this is the very practical things. And also I'm telling very short example right now, and I'll go through this. What type of things will follow in this particular chapters, as I told you earlier. So this chapter, you are, or you all people know what is happening that in electrochemistry. Anyone this that have you heard about this term electrochemistry, or do you have any idea? Anyone can say? I need the answer, yes or no. Do you know? Do you have you heard about the electrochemistry? Okay. So thing is that see, another thing. If I'll say that you have seen that plated for means yeah, on the silver ornaments, silver that ornaments we plate gold. So that is also part of the electrochemistry. How it happens? Prevention of rusting, that is also part of this electrochemistry. So I'm giving you some examples where you are customized with all the process in this case. So let's go to that particular chapter, and it will not one chapter, two chapter, it will completely full of features of several electrochemical process. Okay, let's go to the understand. Okay, now before I'll let go and see that what are there in that. See, structure, what is the structure, what type of things are associated with this chapter. Introduction is there, okay, no problem. I told you the introduction. Basic concept, I told you what is basic concept. You see that why it happens, you will see that you will know that chemistry, one electrode potential value is there already, it is calculated, right? So we memorize that thing, electrochemistry, that value is there, electropotential value is there. Two things, suppose if we take the copper, and suppose if we take the copper sulfate and zinc sulfate, right? You want to coat it over that copper and zinc, right? So what will happen? So in this case, that copper sulfate and zinc sulfate, zinc is one electrode and copper is another electrode. And what? Okay, let's go to that another example. Suppose I put down a nail, means which is made with the iron nail, right? Nail into the sulfuric acid, into the sulfuric acid. If I put down, why am this is my intention is not to that whether you know the that answer of this question or you don't know the answer of this question, that is immaterial for me. I have to start the topic, that electroanalytical methods. So before going to that, so at least I have to refresh something that what you have learned in your past degrees. Suppose you put down, this is simple things, this is a standard 9th 10th students are doing, also we are doing same things, same procedure we are also maintaining, right? In higher studies, same thing, simple things, but it is the simple process is that the students are 8th 9th class, they have done, they are doing in that activities, right? So if you put down one nail which is made with the pure iron in a sulfuric acid, then what will happen? You know that what is the color of pure nail, that is around that gray or gray black, right? Around that figure, it will immediately after some time, 1 minute, 2 minutes, 3 minutes, it will turn the color of that what is that nail will turn into the brown. Why it happens? Because nail that is which is made in the iron, that is dipped into the sulfuric acid, it is changed to the iron sulfate and hydrogen gas released. We are doing this experiment. The small kids of 8th 9th standard, they are doing these activities in their classroom. Also, you people, you have to do this kind of experiment in your room, because this is the basic things you have to understand. Why it happens? Due to the electrode potential. Means two things, one is hydrogen, second is your iron. Between these two, that what happened, that electrode potential is the difference. So that is the basic terminology what I'm going to say, that is thing is that basic concept. You have to understand this basic concept. These are the electrode potential. I told you one fact. Then electrical, or not the basic concept, what will you understand? Electrical units. Okay, electrical units means you have to see ohm, that ampere. These are the electrical units. You well configured. Just I refresh your knowledge before going to the chapter. So these are the electrical that is units you have to use. Basic law of electrochemistry. Basic law of electrochemistry means thermodynamics. Sorry, that Faraday's law of electrolysis. You have to learn about that on Faraday's law of electrolysis. So Faraday's law 1, law 2 is there, right? So we have to understand those things also. Next thing is that if you come down into that liquid junction potential. Okay, liquid junction potential means, see that when two liquids having different junction potential, means potential difference is there. when you add these two, there will be a barrier will be arise between these two, because these two have two different types of potentials, right? One having, suppose let us take one having plus 2.00, another having minus 1.00. Suppose let us have the potential volt, electrovolt. So if we add these two, there will be a potential difference will be created over there. That is liquid potential junction. This is a very interesting part of the electrochemistry or electroanalytical chemistry. Then that electrochemical cell, yes, there is electrochemical cell. You all are aware about the electrochemical cell. What do you mean by electrochemical cell? So that when the electrical that you have to find out the electrical energy from the chemical energy. When chemical energy is converted to the electrical energy, so that is known as that cell, where it happened, in which system it happened, that is known as your electrochemical cell. So we have to understand all this terminology, right? So after that, when you understand this, okay, then is there your next equation. All of you have E cell. E cell is equal to inert cell minus that is NF RT by NF ln the oxidation potential and the divided by reduction potential. So many things are there. So we will have to elaborate that things also. Then cell potential. What I several times I am using this terminology, cell potential. So that we have to understand this thing. These are the basic facts. First, you have to understand these things. All of you are well conversed with this system, but later on we have to expand these things. Okay, let's go to the means we have to go to the basic concept. Okay, see, under the basic concept, first is electrical units. So many electrical units are used. You have seen in front of you, ampere is there. Okay, then ohm is there. It is written over there. It is in your syllabus. Ampere is there, which is denoted as capital A, and ohm is there. Ohm symbol is there, right? And volt is there. Volt, you know that volt is there. Coulomb is there. C represents C. Faraday is there. F. Faraday is having a particular value of that one. So and that is Siemens is there. So that is most important thing, because in that chemistry, so many that's S will use in so many facts. This is combination of three facts, right? Ohm, centimeter, and time, right? So three things will connect to that. We'll come to that point. Okay. So first you have to understand these three units, and sorry, these 5 units, and this is most of this is interconvertible, right? One will convert to the another facts. You have to understand that thing also. How you will convert these things. Okay. So ampere is that ampere. I can say that ampere is the unit of current. If we'll say that 1 ampere, 2 ampere, 3 ampere, 4 ampere, like this. So this is also called the this is that a scientist was discovered, French scientist, that is AM Ampere. His name was the AM Ampere. So due to his name is ampere, this is denoted as the ampere, and also represented as the A. So, and one more thing is there. So that if that a direct current will which pass through the silver nitrate solution, it will pass 1 ampere of current. This is the given here the value. 1 ampere of current will pass through the silver nitrate solution under a certain specific condition, means temperature, pressure, and all the things. So it will deposit 0.00111800 gram per second inverse, right? This much amount will be of silver will be deposited at the electrode. If you pass that 1 ampere of a current, certain specific conditions are there, room temperature and pressure will be there 1 bar. So like this, and it will pass through this one. So then what will happen? 1 ampere current will provide you 0.00111800 grams per second. That much amount of silver will deposited at the silver electrode. So that is the major fact. That is the important fact. 1 ampere will give a particular amount of it helps to deposit a particular amount of that particular substance. So it is an example is given over. So that is next thing is ohm. Ohm is omega symbol is there. You have to memorize this symbol also, omega. So sometimes question will come with this symbol, not with the ohm, that is not in the English word. This is also stand due to one scientist name, that is his G.S. Ohm, and Ohm is the that he discovered this one. So the resistance offered by the uniform column by mercury 106 300 centimeter long, which mass is this much, that is 14.4521 gram, with direct current at 0 degrees Celsius, it is equal to the 1 ohm, right? So you have to memorize this value also. Volt is right, that you know that we are using that 100 volt, 200 volt, 300 volt, like this. So but this thing is that you see that in the last part, 1 volt is equal to the electromotive force EMF, you can say it is EMF, which when applied to the conductor whose resistance is 1 ohm will produce a current of 1 ampere. This is the important part of this particular thing. This is the important part. If you see, so if that equal to 1 volt is equal to the 1 electromotive force EMF, so which applied to the conductor, if the conductor is applied and of 1 ohm, then produce 1 ampere of current. This is the calculative value of these things. So that unit is very important, because I earlier when I started these things, I told you interconversion is there. So you have to be careful about the interconversion. So then Coulomb is the that unusual unit of the express the quantity of electricity. So Coulomb, you can say that value of Coulomb is there, right? Faraday is there. So 1 Faraday is 96494 coulombs. So this see that Coulomb will be converted into the Faraday, and Faraday will convert it into the Coulomb. So this is the scenario, that interconversion scenario is there. So you have to use these things in a particular manner. Okay. Now the thing is that, see, sometimes people see in the mathematical process 96494 coulomb. 1 Faraday is equal to 96494 coulomb. Usually, as you told in the when I taught in the past, means that we are using some very scientific notation, right? It is equal to the 96500 coulomb in mathematical, but accuracy is 494, right? When you are doing any kind of a numerical in this scenario, you have to use accuracy value as it is depending upon your situation, where you have to use, where that what type of things you are using for, right? That so things 96494 coulomb you will use, or 96500 you have to use. You see that significant figure is there, right? So be careful about that. Okay, now we'll come to the part of this basic, then you will go to the, this is the Simon. Okay, so Simon is there, and Simon is the another things I told you. Simon is the this is used for the conductance. You know that. So electrical means when electric current is passed through any substance, so there is two things are there: conductance and resistance, right? So means if you see, sometimes what you are using, that you have to understand what is conductance, what is resistance. I am coming to that point later on. There is also, so conductance means see that usually if you say in the electrical wire, so usually the copper wire is there, right? So inside that copper, not iron, it is copper. Why? Copper is more that is, it is helpful to conduct the electricity more easily than the iron, because the conductance of that copper is more highly that high conductance of the copper than the iron. So iron has more resistance. So that's why, see, that silver is more that is having most conductance power than the but silver is it is costly. So that's why we are not using silver. But the thing is that, and also see, this is the scenario, conductance and resistance, where you have to use which blockages the current, that is called the resistance, which flow that make flow faster the current, that is connected to the conductance. So conductance is reciprocal to the resistance. Okay, now we'll come down to the basic law of electrochemistry. I told you basic law. So laws are, so many laws are connected with the first is Ohm's law. You have seen that then Faraday's law is there. Ohm's law, what is that? You sometimes you have learned about that thumb expressions, right? Thumb expression like this, thumb expression is there. So like this, we use this usually we use, the teacher taught you like this thumb expression, right? This is application of Ohm's law. Right hand and also left hand, both will be applied for the Ohm's law. So the thing is that you are well configured with that on. So, but we have to understand what is the law. The mathematical relationship among three fundamental electrical quantities. So I told you, na. So why three thumbs? Three part of this here. This is one fundamental particles. This is another. This is another. So teachers, when my teacher taught me in the 8th or 9th class, he has explained that physics in this way. Ohm's law. He has physics. He has that physics. Ohm's law is coming in the physics. So that he expressed that one thing like this. Okay. So actually the thing is that three fundamental particles. These three parts represent three fundamental particles. Okay. Now the thing is that when three fundamental particles are quantized, namely electromotive force or E, that is represented in volts. Okay, it is represented in volts. Second is fundamental particles is current, strength, that is I, ampere. So it is in ampere. And third is resistance R in ohms. See that Ohm's law contains three different, what is that, units. One is volt, second is ampere, third is ohms. It is expressed by Ohm's law. The law states that current flowing in a conductor is conductor means when the current, I told you, na, conductor means flow of current. Resistance means blockage of current, right? Simple things. Flow of current, blockage of current. So when the current flowing a conductor is equal to the potential difference, I told you potential difference. See, very beginning I told you potential difference, because which helps to carry that potential strength is more. If it block, then potential strength is weak. It is how potential actually we are using in English also potential. That is my potential. I can go up to this position. This is my potential. I can block at this situation, right? Potential is a very common word, right? So the potential difference between any 2 points divided by the resistance between that. So that's why thing is that now that it will connected with that, it will show I is ampere is equal to, what is that, electromotive electromotive force EMF divided by resistance, or E is equal to IR. This is the expression. So you have to memorize this expression. So relationship between I and ER is equal to, you have to understand relation between I and ER is I is directly proportional to the E and reciprocal inversely proportional to the R. So that way E is electromotive force, and then it will come down to that E is equal to electromotive force is equal to I and R. So that means ampere as well as resistance. So you have to express, see, from this point you have to get your, what is that your unit, different units, I units, then E units, R units, all units will be put. So E is in E is in volt, then I ampere, that is I is in ampere, and also that is what is resistance, R is in your ohm. So you will get your what is that relationship between these two or three things, right? Three things you will get the relationship. Now we'll come down to the Faraday's law. So Faraday is a scientist who expressed the law, and here he expressed two laws. Here is only one law is given. Okay, no problem. So Faraday's law states that quantity of a current means, here the current, you know that coulombs means C. Okay, associated with an electron transfer process is directly proportional to the number of equivalent of the substance involved in the chemical change in the electron. Okay, so that thing is that, as you know that, so flow of current is opposite to flow of electron. Electron, if pass the left to right, then current will pass from the right to left. This is the simple procedure you have learned this in the electrochemistry in your last degree. So that is, see, the electron, that a transfer process is directly proportional to the number of equivalents of the substance involved chemical change at the electrode. So when electrode differential will created, I usually electrode between two electrode, when differential process will be there, difference means electrode potential value difference will be there. Suppose this is two electrode, one is this, another is this. So if there is two, that is electrode potential value is difference is there, then what will happen? That from one to electron will flow another side. Then what will happen? Current will flow from the opposite side. That's why the generation of anode and cathode happened. As you know that oxidation happen and reduction happen, anode and cathode is originated in that case. Okay. Now we have come down. So that means So Q means it is the amount of that is charge. Q is the charge. Is directly proportional number of equivalents. So Q is equal to F into number of F means Faradays. It you can put 96500 C or 96494 C. You can put the value of that one. So and number of moles that you can find. Now N is the number of moles of electron what is the passing. So this is the formula of the what is that Faraday's law. Okay. Now come down. So then our point is electrode potential. Okay. Now check it out. Electrode potential. See, it will come down to this diagram. Check it out. This diagram. Okay. So this diagram that one electrode is there copper, which is in the light little yellowish in color, and zinc it is gray in color. Okay. So copper electrode is dipped in the copper sulfate solution. Then zinc electrode dipped in the zinc sulfate solution. Okay. Now what will happen? See, in the picture of zinc, so that plus is outside and a minus is mentioned inside. Zinc minus in the zinc electrode you will see that is minus negative charge is there, and outside of that one positive charge is there. In case of copper electrode, see positive charge is inside that yellowish area, and outside that transparent area, white area, that is minus charge is put. What does it mean? This is the things you have to understand. See, that copper, when passed to the copper sulfate, the copper electrode dipped in the copper sulfate solution. Then what will happen? There is a copper sulfate, CuSO4, then SO4 2 minus is there. On the SO4, you know that 2 minus charge will be there. Then by default, if 2 minus charge is there, then copper will be in positive charge, 2 plus charge is there. As you know that copper have two states, one is plus, Cu plus and Cu2 minus, right? So this is two that is oxidation state of the copper, one Cu plus and Cu2 minus. Here Cu2 minus is there because sulfate ion is there. So when sulfate ion is there, so 2 minus charge is there. By default, 2 minus means what? 2 electron is accepted by the sulfate ion. Okay, then what will happen? Copper has to give 2 electrons. That's why in the copper, inside the copper, that yellowish area, 2 charges are there. One plus, 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 plus. See, both, but in the first plus, plus is there, means 2 plus. Then second also 2 plus. Third 2 plus, 2 plus. Again that in the outside 2 minus is there. 1 plus carry another minus. Second plus will carry another minus. In the zinc sulfate, what will happen? When sulfate ion, see that electrode potential, sulfate always 2 minus. So then what will happen? Zinc will release 2 electrons. When that actually, if you understand that thing, that salt breeze is there, na? Salt breeze. So that's why that electrode potential created. So when the electrode potential means difference created, one will attract the electron. When copper has 2 plus charge, so copper needs electron because I have deficient of electrons. I'll pull the electrons. So that's why when I pull the electrons, so through the salt, I will go to down that particular things. If you go down the picture, if you understand that in, yeah, this is another thing. Yes, here in this galvanic cell, see that right side there is copper and left side there is zinc. When copper has that donated 2 electrons to the sulfate ion, then copper is deficient species. Then it will pulls the electron, and this particular KCl will diverted because sulfate ion is in minus. Sulfate ion in the copper sulfate solution, sulfate ion is the minus state, right? So it needs attract the plus charge. So KCl, which is that what is that agar gelatin solution, which is present in that glass tube, salt breeze, inside the salt breeze. So that KCl is used, potassium chloride. The potassium will attracted by the sulfate ion, then K plus come to this side, and see that zinc will attract, zinc will be in the plus state, and it will means sulfate here that donated the electrons, so that's why it is in plus state, and Cl minus will come down. So that is why, because this is the condition when the electrode potential arises. So when electrode potential will be arises, then charge will flow. It helps to the development of the potential difference. So we'll go to this one. Okay. Now we'll come down. See, another interesting fact, this is the what I told you, liquid junction potential. See, liquid, I told you, when I come across that terminology, I told you that what is liquid junction. So liquid, when two liquid, here if in the picture you see that one one is HCl, here is HCl, but the concentration in the left hand side but the concentration is 0.1 molarity. In the left hand side, so if you see, HCl is there and it is a liquid, that is, you cannot take two different types of liquid, but concentration, same liquid having different concentration, you can take it. If okay, now I'll come down, I'll explain these things in other way. If that I'll take two, that is what, glass rods and connected by another rod. Two glass rods, two glass, not right, glass, that is what is cylinder. Two glass cylinder, and which is connected with another cylinder. Means actually it's a equipment, right? And that middle one, which is connected cylinder, that connected cylinder will stop by a stopper. In a left hand cylinder, I'll take only water. In the right hand, that is cylinder, I'll take salt water, and stopper is closed. Now what will happen? I'll open the stopper. Then what will happen? The salt water, both are having same quantity. Means if it 200 ml, this side is left hand side is 200 ml and right hand side also 200 ml. So water will not flow. Water will not flow, but the concentration of a salt is higher in the right hand side and concentration of salt is lower in the left hand side. Then what will happen? Salt will flow. That water will not flow. Only the salt will flow. Till what time? When the equilibrium state will arises. So that my point is this, that one also. See, if we apply same thing here. So in the left hand side, hydrochloric acid is given. It is 0.1 molarity. And the right hand side, hydrochloric acid is given, the molarity is 0.01. Okay, now the thing is that concentration of right hand side is less, concentration of left hand side is more. Then what will happen? Higher concentration, this is the principle. It is the principle. So higher concentration to lower concentration. So that's why when the two liquids will start its combining state, so that phase where they will meet together, that is called the interference. So interference area, that will be created. If you see, you can understand these things more easily. If it is water and oil, you can see, you can do at your own, at your home also. You will take water in the glass, you will take some water, then pour some oil, whatever type of oil you can use. Okay, it's maybe coconut, maybe mustard, maybe palmolive, whatever refined you can use. Okay, oil, but that density should be higher. So you will see that there is an interference here. Interference. So that's two things will not mix together. This is permanent, but in this case, this is not permanent. That means left hand side 0.1 molarity concentration is there, and the right hand side 0.01 molarity concentration of hydrochloric acid. Both will dilute hydrochloric acid. So interference will be created, but later on it will be come to the equilibrium state. So that is liquid. What interference is created, that is what you say the liquid that is junction potential. You will go through that one, you will read that. Okay. Next, if you come to the point, next we will go to the another point. This is very important. Electrochemical cell. What do you mean by electrochemical? I told you also. What do you mean by electrochemical cell? Electrochemical cell is a cell, is a container, it's a system where the the chemical energy will convert it the electrical energy. Chemical energy will convert it the electrical energy. Okay. Another thing is that this is the electrochemical cell. Another thing that is okay. That is this. Let me explain this one. Electrochemical cell first. So this is chemical energy will convert to the electrical energy. Where battery. Inside battery, if you see, if you break down your remote battery, you will see when a graphite rod is there and some black substances are there. Okay. So that is chemical energy. If you'll see, if you open your that is one battery of that is your vehicle battery, you will see two potentials will be there, and there will be chemicals will be there. It will convert to the electrical energy. Another cell is the electrolytic cell. What is electrolytic cell? It is electrical that is energy will convert to the chemical energy. See, this is the most interesting things. So why we are coming to the electrochemical cell? All of you are configured with that rechargeable battery. Okay, I am telling you I am giving you two examples. One is your remote battery. Second is your mobile battery. Mobile battery is a rechargeable battery. Okay, but remote battery, what? Okay, maybe you can say, sir, we are using rechargeable battery. I am not telling about the rechargeable battery. Okay, so use and throw battery. That I am going to say about that. Okay, another thing is mobile battery, rechargeable battery. So once if you use that remote battery, once you open and put down into a system or any kind of electrical gadget, right? Once it put down into any electrical gadget, then what will happen? So that function started inside that battery. If you again bring out and keep and will I'll use later on 15 days, 20 days, 1 month, that will be damaged. But thing is that when you are using this, what is that? Your mobile battery, right? Rechargeable battery. You are keeping out, then putting means from your mobile or from your camera, from anywhere else, you will keeping away from your that is electrical gadgets. Then you will put another sometimes recharge and put down. How? Okay, now I'll come to the of this mechanism part. This is very much important mechanism what I'm going to say. Okay, let's have there is another thing is there below this galvanic cell. Okay, below that galvanic cell is there. Okay, it is written over there galvanic cell. Let me to I'm not going to the galvanic cell, but I'm going to say you one thing. This galvanic cell will produce 1.1 volt of current. I'm telling one very particular things. Galvanic cell, this is the primary cell, what you say. So this cell only generate 1.1 volt of current. Got the point? 1.1 volt of current. Okay, now the thing is that, okay, that galvanic cell is providing or generating 1.1 volt of current. Okay, fix. Now, from external source, I connected another external series outside. External series I connected to the galvanic series. Okay, where that 1.1 volt current is there. I'll set another external series and I provide external current also. Okay, then what will happen? Suppose we can we can take in three different examples because three cases maybe happen. Okay, one, what is that external circuit may provide more than 1.1 volt. I don't know. Suppose let us case one, that external that a circuit providing 1.1 volt, more than 1.1 volt, because galvanic cell is providing 1.1 volt. I am providing from the external circuit that is 1.9 volt. Case one. Second case, what will happen? I'll provide that equal 1.1 volt of current from the external circuit outside to that galvanic cell. Third case 3, what will happen? Let us provide that less than 1.1 volt, means it had 0.9 volt. Let's provide from the external circuit. Three cases I have. This probability, three probabilities are there, right? When I provide less than 1.1 volt from the external circuit, so the behavior of the battery as it is, means it will, how the, means anode behaves like anode and cathode behaves like cathode. There are no changes at all, no behavioral changes. Okay, as it is. Zinc, if galvanic cell will go, so zinc behaves as anode and copper behaves as cathode. So it will provide less than 1.1 volt into that circuit, into that cell, galvanic cell. So zinc will be as cathode and copper will be as anode. There is no changes at all. Next point, case 2. If it will come down to the equal amount, means galvanic cell is that is giving 1.1 volt, as well as I from the external circuit I will provide 1.1 volt. Then what will happen? Do you know that there will be no reaction, means chemical reaction will not be happen. Why? Because potential difference is equal now. That what is the potential of zinc electrode is equal to the potential of copper electrode, because both having the same amount, external and internal. We both are equal. If we play tug of war, you know that if force will be equal, so there will no changes at all. If you know that resultant force, if you understand the resultant force, so that is the same thing. So here that both sides, means external and internal, both having 1.1 volt, so there will be no reaction. That means what will happen? There will be no generation of a current. Volt will be zero. Reaction will be stopped. Okay. Next, come to the case number 3. Case number 3. If you come down to case number 3, then what will happen? When you put more, means more than 1.1 volt to the circuit, more than 1.1 volt to the circuit from the external circuit, right, to the galvanic cell, then what will happen? The behavior will be changed. Here the cathode will be behave as like that anode, and anode will behave like cathode. So that means anode, zinc was the anode in galvanic cell. Right now, when will external volt will be more, then zinc behavior will be not anode, it will behave like cathode. Copper, it will behave like anode. So these things happen in your mobile battery. When electrical current, means mobile battery down, battery charge down, then we'll put the current, external current, when plug in the external current and go for the charging condition, then what will happen? It is recharged. Means cathode will be anode, anode will reverse reaction will be there. Then store. So that is, but thing is that when in case of that, so it will not happen. It will, the reaction will be stopped. So this thing is most important part of the electrochemical cell. Okay, next will come down. If you go to the galvanic cell, see, so galvanic cell is connected with the two electrodes, two containers are there. One is oxidation half, second is reduction half. One is oxidation half, second is reduction half. So if you come down to oxidation half, zinc electrode is used in the oxidation half. Why zinc? Why not copper? Because there is electrode potential, that is difference is there. There is electrode potential difference is there. So that's why zinc and copper has, copper is two values are there, right? I'll tell you, just I forgot that value of that one. Just let me to give that. Just a second. Just a second, please. See, around 1 point something. Okay, copper is 0.34 volt and zinc is minus 0.76 volt. Okay, so who has lesser value, that is zinc? Zinc will behave as the reducing agent and copper behaves as the oxidizing agent. So thing is that's why that the electrode potential value is different, and is minus 7.6, 0.76 minus 0.76, and one copper is having the plus 0.34 volt. So two having the electrode potential value, that's why this means movement of electron happens, and then electrical current is generated. So these are the things in this case. Okay, now we'll come down. Okay, now see that zinc releases electrons, Zn2 plus, 2 electrons release, copper accept 2 electrons, and copper, when I told you that copper, when initially copper gives 2 electrons to the sulfate solution, so Cu2 plus becomes, so when it accepts 2 electrons, it becomes again that Cu, right? So thing is that, okay, now that this is the method of process as that thing. So E cell, now the that E cell means that electrode potential difference, what will happen between these two is that E cathode minus E anode. It's actually that right and left, I don't prefer these things, but it is okay, no problem. But E cathode and E anode, because usually cathode is the right electrode is used as the cathode, and the left electrode is used as the anode. So usually we wrote that E cathode and E anode, right? So E cell is equal to E cathode minus E anode. Note down this formula. This is essential for your electrode potential to find out. So that means if you say that zinc and copper, so that E cathode is copper, that means plus 0.34 volt, and zinc is minus 0.76, then what is the electrode potential? Plus 0.34 volt minus of 0.76. So that means altogether just calculate around that 109 or 110 volt of that is electrode potential will be created. Okay. So this is the things. Now come down some that here is some. Okay. Then we'll go to the Nernst equation. So see that this equation is very actually derivation you have to memorize. You have to understand this derivation. But honestly, I told you that when the application part will become and a mathematical calculation will be there, so you have to directly apply Nernst equation. So direct application of Nernst equation, I'm telling you. So that E cell is equal to inert cell minus 0.0592 log of that potential of oxidation divided by potential of reduction. So many things are there. Potential of oxidation divided by potential of reduction. We can take it as Kc. So many things are there. That is not the issue. Issue is oxidation potential and reduction. That is concentration. What is value is given. On the basis of that, you have to calculate. So here Nernst equation, how it is the derivation is important. It may comes in your examination. So that is you have to go through this one. This area is most important. See, that is written here, derivation of Nernst equation. So this may comes in your long type questions. So be careful about that. This you have to digest these things. So there is no difficulties at all because you have to understand so many things here over. So last you'll see that last thing is part of this one is equation is C. Here is the okay. Now we'll come down this the that is Nernst equation. So E cell is equal to inert cell This is minus j. Actually, this thing is somewhat, there is just some mistake here. Let me check it out. Actually, dear students, there is a mistake here. Okay, that is my, okay. Here they have put the value of minus. No, this formula has some mistake. Okay. Okay, see that last one is there. It is correct one. 0 minus 0.0591 divided by n. N means that is the number of free electrons is there. You have to calculate this one. Okay, so this is the last part of this one. So E cell is equal to inert cell minus 0.0591 divided by n. This is n. You have to find out the n, value of n. How many electrons are you have to balance? Suppose I told you one equation. Suppose you are using Fe, that is copper sulfate with a what is hydrogen, platinum, right? So suppose that in the copper sulfate, so that is 2 plus will be there, and in the platinum that is 1 plus, 1 electron will be there. 2 plus, there is 1 plus. 1 electron is donated by the platinum, and but here is copper is accepted 2 electrons, from where another electron will come. So we have to balance the reaction. So we have to, in copper case, we have to multiplication 1, and in the that is platinum case, we have to multiplication 2. So 1 and 2, when the cross multiplication will be there, so both having 2 electrons. So here the n value is 2. It will come down the zinc and also copper, zinc sulfate with the copper sulfate. So that what will happen? Cu2 plus as well as zinc 2 plus. So 2 plus 2 electrons are there. Zinc donated 2 electrons, copper accepted 2 electrons, then 2 electrons are there. So that means n value is 2 also. Okay, so thing is that on the basis of that, you can calculate the that is n value, right? On the basis of that, you have to calculate n value. Okay, now the thing is that let's go to the cell potential. Okay, just a second. Okay. Now the cell potential. Now the cell potential. So thing is that the potential difference between two electrodes, what I told you earlier also, so connected properly to form a galvanic cell under the condition where no current flow through the system is called EMF of the cell or cell potential. So that is two things are there. So when two electrodes are connected, so by that time there is no means the chemical energy or electrical energy used. So two potentials is there. So as I told you, so copper having that plus 0.34 volt, as well as volt is the unit, and also zinc having that minus 0.76 volt. So things are there. That is electrode potential. So E cell is equal to E right, that is E cathode minus E anode. You have to use that one. Okay. Now the standard electrode potential that is okay. So this is the process how to calculate the numericals. So numerical, you have to put the formula for that is what is that your Nast equation formula. E cell is equal to E naught cell minus 0.0592 divided by n. You have to find out the value of n. Then you have to put the value and the oxidation, what is the concentration is given. On the basis of that concentration, if you go here, so here is the numerical given. Okay. Just a second. Okay. Now the thing is that so this is the part of that cell potential and all the things. Now we'll come to the classification and overview of electroanalytical methods. Okay. So this is the basic things. Already you have taught in so many areas. So now we'll go to the MCH-1. We have discussed about the potentiometry. So we'll go to the potentiometry, and the technique involves the measurement of a potential at zero current flow. Okay. Zero current flow means no chemical reactions, no external circuit used. It is zero current flow, right? If I also told you, when battery is made, it is packed, and you just it is zero current flow situation. When it is connected, then current flow started. So that is measurement of that things. So that this technique involves the measurement of a potential at zero current flow. Analytical use of these techniques is made. See that sometimes if we measure, that is, if we bring out one battery, that is your pencil battery, whatever you use in the that remote, that not rechargeable, that you will measure the current of that one without any function, that will give 1.5 volt of current. When it is coming to work condition, or after working, sometimes if we measure, the value will be decrease 1.3 1.5 to lower. Okay, the value will decrease because energy used, that is reserved energy used. So that's why the value will decreases. So that what is the amount of current present, that we have to measure. See that battery when comes, we don't know what is the amount of current is there. So potentiometry, the work of technique of that, so it measures without consuming any kind of energy, without that use of that battery. So it will measure that how much amount of that is volt, how much amount of current is there, that is reserved current is there. So that is why that this potentiometry is important. So analytical use of this technique is made in two ways. In one, known as the direct potentiometry. In this technique, we utilize the single measurement potential, and the Nernst equation is used to relate the potential cell potential to the concentration of the analyte. So things that here is two methods are there. One is direct potentiometry, and one second is potentiometric titration. Right? Two things are there. One is direct potentiometry, and second is potentiometric titration. If you come down to the direct potentiometry, so in direct potentiometry, we measure a potential difference between two electrodes immersed in a solution and connecting the cell. So formed a voltage measuring device, that is potentiometer, vacuum, or voltmeter. See that two currents, how much amount of is there. So when two that current, that both the cathode and anode part or oxidation of reduction are connected with the voltmeter or potentiometry, it will indicate that how much amount of current is there. That means we can understand that is 1.1 volt, 12 volt, or 19 volt, or 16 volt, how much amount of current is preserved there. Okay. So that is the work of potentiometry. It is a very simple process. That usually electrode half cells is chosen such that the potential is invariant and in terms of the reference electrode. The potential of the other electrode is then function as the electrode mode of the activity of the species. That by using the okay. Now the thing is that here you can see that this particular things I have taught you in that potentiometry. So that E cell is equal to E indicator minus E reference, and plus what is liquid junction, value of liquid junction. If you put this value, you can find out that what is the direct potentiometry, what is the amount of current preserved in this case. Okay. Next, if you go to this equation, already I taught you. Okay. Now nothing is there. Okay. Potentiometry. Then next process is potentiometric titration. By we have not actually these things we have already discussed. By far the most common application of the potentiometry is the potentiometric titration. In this titration, the potential between appropriate indicator and reference electrode immersed in a sample is monitoring during the titration. So in this case, what will happen? You have to do the titration. One is will be there in your what is reference that is thing. Another will be your that is what you say that indicator. Suppose if you come down in the titration, if you see that titration one will be used in the burette, second will be used in the that is you take the in pipette and also in the beaker, right? So burette and pipette. Burette is your what we have taken in the burette, that is your that is reference. So what you are taking in that pipette, that is your indicator. So these two things are there. On the basis of that, you have to use that where is the reference electrode, which is your that is so in this case, you can use the equivalent point is detected by the abrupt change in the potential and can be determined by any of the following three procedures. One is tangential methods, second is fast derivative methods, third is second derivative methods. So further details of these methods will be discussed in the 2 and 3. So further three things you have to memorize these things. Then another thing is voltammetry. So things that in voltammetry an electroactive species is consumed, oxidized, or reduced only at the surface layer of the indicator electrode in an electrolytic cell. The resulting current due to the electron transfer process is measured at the see this it will come down this picture. It will come down this picture. You see circuit diagram of current potential characteristics. See, this is the this is the voltammetric system. If you go through this, you just go through this circuit once and just read that lower part and upper paragraph. Okay. So in this case, in voltammetry, we study the relationship between the current and electrode potential and their application to the to chemical analysis. See that here, that voltammetry means you have to understand the what is that relationship between current and electrode. If current is passed properly in the electrode, the flow is fine, then chemical analysis, what kind of a chemical you are using, that is particular system is correct, okay, no problem. But if there is any difference create, means any electrode potential and current flow is not proper, then it is not suitable use. So that's why this is essential procedure for the industry. The current potential characteristics are studied commonly with the arrangement which the voltage applied to the cell C is adjusted by means of the potentiometer P. See that P is written here, C is written here. That is, this is the circuit potential, that potentiometer is used here, and that one galvanometer G is used here in this potentiometer. Then you can observe this calculator. This is a physical that is method. Okay, that is studied by the how the chemical is behaving. Okay, next it will come down one. Okay, then polarography. So this is an interesting method, polarography. Various types of electrodes can be used in voltammetry, but one of them, the dropping mercury electrode, is particularly useful, and the corresponding voltammetric method is referred to the polarography. So when that you are using this voltammetry, polarography is a part of voltammetry, right? So it is in this case, but only the thing is that you have to use mercury is an by the electrode, right? When mercury drop down, so then potential difference will be created. So here this, if you see this diagram below, so there is a mercury meter, right? So you see that there is a mercury which is gray in color mercury meter. So when the potential difference will be created, so that means the mercury will drop down and things will be the saturated calomel electrode will be off. So then electrical difference will be created, and we can observe this in the your differential potential. So this is the simple method, but it is a very connecting method, right? When mercury will drop down, means it will drop one by one, right? Drops. So on the basis of that, we can calculate these particular things. Okay. Okay. Now the thing is that this is the scenario of this one. Okay. Amperometry. So in polarography, we have seen that in a particular polarogram, the limiting current of the electrode substance at a suitable potential depends on the substance concentration only. If we reduce the concentration of the electroactive substance by its interaction with another substance, the current will be reduced. See, this is the process. If you go through this process, so that means here polarography, we have seen that the particular polarogram, the limiting current of the electroactive substance at suitable potential depends upon the substance concentration only. So thing is that in polarography, but in the amperometric titration, what will happen? Amperometric titration are more accurate than the voltammetric methods. It is more accurate methods. So remember these things. So furthermore, this titration, the titration can be performed even when the substance being determined is not reactive. Furthermore, the titration can be performed even when the substance being determined is not reactive. That's why it's important. What happened that any voltammetric, for the voltammetric titration, so things that substance should be react. But in this case, amperometric, there is no reaction should essential. So that's a more accurate thing should be there, and it's a highly applicable area. Since an equally satisfactory equivalent point can be located with either a reactive titrant or when the product is reactive, modifications have been made by the use of amperometric indicators on plotting the data for the current versus volume of titrants we get straight line having different slopes. So that is that is most important. The microelectrode is the indicator, maybe DME means dropping mercury, or a solid state platinum electrode, or rotating platinum electrode is essential, or an electrode of any other inert materials. Inert means non-reactive materials. So that is the things. Okay, now we'll come down electrogravimetric and coulometric. So the process in this case, Faraday's law of electricity gives a direct proportion between the quantity of electricity and the amount of substance consumed or obtained after oxidation or reduction taking place. As you know that, so that is a law of what is that? Faraday's law. So that when the unit of current is passed for a time period, So in the electrochemical cell, two electroanalytic techniques are based on these above statements. They are electrogravimetric and coulometric. So these two are things which is used, which is based on the law of Faraday's law of electrolysis, and the base it is developed. So if you go to the electrogravimetric, it is the oldest of electroanalytical techniques, and as well as established by the end of the 19th century. This is the oldest one. And the practically, if you see, the method is very simple. Okay, the analysis of single element in the absence of any other substance which might be deposited. Okay, so that means method is very simple. So analysis of single element, any element, if you see that people find out the copper or zinc or iron or silver or gold, whatever may be, element is absence of any other substance, then what will happen? So see, if that electrical difference is there, but thing is that we have only using only electrode, that is silver electrode. So silver nitrate, from silver nitrate, silver electrode, you will dip silver electrode in the silver nitrate solution. Then what will happen? Silver will deposit it at the silver electrode end. So that is the meaning of this one. It's a very simple process. Only one electrode, there is no potential difference. There is no potential difference. There is no two electrodes, more than one electrode. One electrode will dip in that. But suppose zinc sulfate solution, it will in that zinc sulfate solution, you put down zinc. Then what will happen? Zinc will deposit it at that particular electrode, zinc electrode. Copper sulfate solution dipped in the copper sulfate. So copper will deposit at that is the simple process. Okay, practically the metallic deposit should be smooth and strongly adherent, that so that you see that what will happen sometimes that it is when the extraction of elements arises, when that we are doing the extraction of some elements like that sulfide ores, nitrate ores, nitrate, sulfide, then what is sulfate, carbonate. If some that ores are there and you are extracting some things, so you have to use this method. This is very practical things. Suppose we have that okay, we have to extract silver from silver nitrate. We have silver nitrate as that ore. Silver nitrate ore is there. Okay, we have to make it a solution, silver nitrate solution. Then we'll put down silver that electrode into that. Then electrolysis will be do. So when we'll do the electrolysis, then what will do? That silver will deposit at the silver that electrode. So that process is for the use for the that extraction, chemical extractions, or that metallic extraction. Usually this process is feasible for the metal, only for the metal. The C that is the deposit of the C. So many things are there. Here is cyanide and ammonia complex provide the best deposit. Okay, if people see, if you take the that is what is ammonia related compound, you if you take that is ammonium chloride, you want to that extract chlorine gas from that, so you can use that. Okay, if cyanide, if you are using that what is that hydrogen cyanide, right? So if you release that that is what is hydrogen gas from that one, you can use this process also. Okay, then coulometry. So in the bulk electrolysis method, when the amount of a constituent to be determined is not waste, but calculated by measuring the quantity of electricity, and see, it is the quantity of electricity. So that's why coulometry. So and making use of Faraday's law, the technique is called coulometry. So here Faraday's law will be, you have to calculate that value on the basis of the how much electrical current you are passing through that one, and on the basis of that, what is the amount of quantity of particular things deposited, whatever may be, it may be that metal is deposited, right? This method is known as coulometry method. The term derived from the coulombs and the quantity of current. So that's, it is as the coulomb, the content means amount of current is there, coulomb. So that is why coulometry methods is there. Okay, you have to go through this one. There is no other things. Okay, then potentiostatic coulometry. Then two types of coulometry that is method is there. One potentiostatic coulometry and is amperostatic coulometry. So in the potentiostatic coulometry, static coulometry, that is the coulometry at a constant potential. The potential of the working electrode is maintained. See, that is your amount of deposit passing through the time and current. How much amount of current you passed, how much time you passed. So on the basis of that, the amount will be deposited. That is potentiostatic coulometry. Then amperostatic coulometry or constant current coulometry. Here the current is constant, but in that you in this potentiostatic coulometry, current and that time will directly proportional. But in this case, current is constant, but time is directly proportional with fixed current. So IT is equal to Q here. So that is the thing. You have to go through this. Then we have to go the conductometry. Okay. Then we go to the conductometry. Methods which involve the charge transport by the ion in a solution are termed as conductometry. So here the charge will be moved. So charge, how? Charge means one species should be may have the positive charge or that is negative charge. If it is positive charge, it is a cation. If negative charge, it is anion. So charge on the basis of that ion, so it is migrated. So that will be calculated. So conductometry methods. Under this condition, the resistance of the cell depends upon the velocities. See, I told you about the conductance and the resistance. The resistance, if increases, the flow will decreases. If the charge flow will be decreases, I see that I think is that very basic facts is flow of current is opposite of flow of movement of charge. Electron, you can say the electron. If electron will be flow properly, then a current will flow properly in the opposite side. So that's why if resistance, I told you, resistance will increases, then flow of charge will not be proper. So then what will happen? The electrical current pass will be that electron flow of electrical current will be decreases. So that's why we usually use that copper wire instead of iron. If you use iron wire, that is more cheaper than the copper. But thing is that it is more effect when the things is that cost effective will be there in point of view the that is production and that is coming to the domestic use or any commercial use. That's why copper is used. So that is here how much amount of this thing will be that can be calculated. Okay, the methods of involving charge transport by the ions in the solution are termed conductometric methods. How much charge with reference to the resistance. Under these conditions, the resistance of the cell depends upon the velocities of the ion and the number of migrated ions. See that if more number of ion will be transferred from one anode to cathode, then what will happen? The resistance will be less. If resistance will be less, then what will happen? That flow of current will be more. If flow of charge will be less, that means resistance is more. So as I told you, resistance is reciprocal to the conductance is reciprocal to the resistance or vice versa. So if resistance increases, that means flow of charge is less. So flow of charge will be that less. That's why the current flow will be less. So that is why that this process will be help to find out how much charge will be passing from the that is this migration of ions. Okay. So this is the principle. That principle, Wheatstone bridge. Okay, that is the important thing. Wheatstone bridge is there. One circuit diagram is there. Okay, let me just check it out. Wheatstone bridge is there or not? No, it's not. Wheatstone bridge is not there. Okay, let me find out the Wheatstone bridge diagram. Okay. I'll share with you. Just a second, please. Just a second, please. I'm sending you just. Now you can see this is the Wheatstone bridge. So on the basis of this, so we can use that the principle of this Wheatstone bridge can be used to measure the conductance of the solution. Okay, so by using this Wheatstone bridge, you will see that things are there. So that is resistance was there, and that is Q is there, means amount of charge is there, potential is there, and that is ohm is there, right? So on the basis of this, we can calculate the electron potential. What is the how much amount of current is passing through? So that's why this thing is helps to find out the that particular things. Let's go to that chapter. Okay. So this is the that what I showed the Wheatstone bridge. So since the direct current would polarize the electrode in the conductivity cell by the electrolyzing the solution, therefore the avoid polarization of the alternating current using by the voltage 3 to 6 volt of the frequency. That circuit will calculate that one. So no need to things, no need to go for this one. Okay. Classification and relationship the electroanalytical method. See, there is a fast classification of this one, electroanalytical method. We'll see. This is the classification. So first is electroanalytical method. It is interfacial method and bulk methods. So under the interfacial methods, that is static method, dynamic methods. In the under the bulk method, that is conductometry and the conductometric titration methods. In that static method, it is potentiometry, potentiometric titration. And under the dynamic method, that is controlled potential and constant current. Okay. So this control potential is the constant electrode potential, coulometry, then voltammetry, then amperometry, then electrogravimetry, right? And the thing is that the constant current method, that is coulometric titration and electrogravimetric titration. So these are the complete that representation of your chapter, what we have to finish with, right? So okay, now the thing is that okay, so this particular things what is connected, well connected with the previous that your system and techniques. So I have finished that one, so that you have to go through this one. All of you have this particular that screenshot, all screenshots. Do you have this material?
Yes, sir. This is our study material.
That is that I told you that study material, because that the questions will come from your study material, but simultaneously I will provide you the notes.
Okay, sir.
Okay, that's fine. All of you have the study materials. Okay, that's fine. No problem.
Yes, sir.
Okay. So I'll provide you that all that. This is the basic things. What is you have, but the second part which is coming on your way right now. So that is the technical part. We have to understand these things. Okay. So now the thing is that right now that is which is coming on your way, that is your very specific things, potentiometry. So this particular unit is only the use of potentiometry and all the things, how you will use, how you will calculate, means very that is what is you have to go all the things about the potentiometry. So that level is will be high in this case. So that is what we have read, that is already what is that is there is you have studied in some sub segment and something somewhere else, but right now we have to study about the potentiometry and application of potentiometry like this, where if electrode is there are different type of electrode is used. So in that case, what type of things you will do, how will to do. So all the details of the potentiometry and the indicators and all the things, so we have to discuss. So if anyone has any questions from the unit 1, that is what we have covered, you may ask me. Okay, all of you submitted your MCH-1, what is that, assignment?
No, sir.
Not submitted?
No, sir.
Why? Because when the submission time is when have you received the assignment or not?
Yes, sir. We received assignment question copy, but mentioned there that is submission will be started from 1st March.
Okay, submission will start on 1st March. Okay, that's fine.
Yes, sir.
Okay, okay, that's fine. But all the means MCH 1, 2, 3, all that are from March 1 or some MCH 1 from the March 1.
No, sir. All the papers. 4 MCH 1 to 4.
That means you have to do your job, right? Okay,
Yes, sir.
okay, that's fine. Uh, okay, anyone has any questions? Okay, no problem. So you people have, if any issues, anything else, I am on WhatsApp, right? So anything else, if you have any problem, any issues, you just communicate with me.
Okay.
That's fine. Regarding this assignment, all this, any doubts in the questions and all the things, you can communicate with me. I'll supposed to help you. No problem. Okay. Now this potentiometry 1 means 1 is there, means 2 will be there, right? So thing is that actually the difficult area is started right now. I think so this is the last your MCH-4 is the last one, right, for the semester.
Yes, sir. MCH 4 is last.
1, 2, 3, 4. So actually this particular the semester, this area from the here onwards, so difficulties arises, means some technical things are there, we have to go through very details on the basis of that. Okay, so potentiometry 1, very particularly we have to read what is the use, what is the behavior, how does it work, how it will implement, where it will be implement, and how does it work, if different if that is metals will use, suppose for hydrogen something will be there, for copper something will be there, for zinc something will be there. So that is different electrode it will use, so different types of methods you have to use, and what is the process of that. So introduction, objective, potentials. Okay, under the objective, potentials are there, measurement of potentials are there, then direct potentiometry, reference electrodes, what you have to indicator electrodes, that is most important area. This is that's a practical, for the practical knowledge. This is, I am not telling about the theoretical knowledge. Determination of equilibrium constant, potentiometric titration, that location and end points, types of potentiometric titration, then terminal. See, very less number of facts are there, but it is interesting one. Okay, if we come to the objectives of a potentiometry 1, what are the objectives of this one? Explain the principle of a potentiometric method of analysis. How the potentiometric method work. Okay, so that is one point. Second is discuss the method of operation of a potentiometry. So how the potentiometry works. Okay, what is the setting, systems, and all the things. Then third is describe some common types of a reference and indicator electrodes. Which reference electrode used to which indicator electrodes, right? So that is important things. You cannot make it cross. Calculate the equilibrium constant from the cell potential. How you will calculate the value? That is numerical area, your calculation part. Describe chemical reactions involved in potentiometric titrations. How the chemical reactions will happen, what will be there, and other things. Explain the principle of a potentiometric titration. how the potentiometric titration will be conducted, principle, rules. State the experiment details of neutralization, redox, then precipitation and complex reactions. Okay, how these experiments will be done. Okay. These are the things we have to discuss. You see that weightage of the that phrase of lines. Okay, potential, Nast equation. One, if you'll see what I told you about the Nast equation, how it happens that thing. Okay, let's go to the thing, because initially I just explain the things, because later it is connected part. So zinc electrode, let us take a zinc electrode and put down which electrode you are taking. You have to put down that salt solution. You cannot take zinc electrode into the copper sulfate solution or a hydrochloric solution. It is not possible. Or sulfuric acid. You have to put zinc electrode into the zinc sulfate solution. Okay, then what will happen? Zinc is the metal here, and you know that metal will release electrons. That is the most means very honest behavior of the metals due to the electropositive nature. Metal will release electrons. So zinc will release 2 electrons to get the stable configurations, right? Because zinc sulfate is there. Sulfate will 2 minus and zinc will be take 2 electrons. Okay. Now the thing is that here, if we come to this point, N plus, suppose M is zinc. Zinc N plus means zinc release 2 electrons. Metal release number of electrons. So that much electrons will go. If I have, suppose if you come to the copper already I told you, copper dipped, copper electrode dipped into the copper sulfate solution. Then there is a potential difference between copper and copper sulfate solution. Sulfate will be 2 minus, copper will give 2 electrons. Then what will happen? Now copper is it is not in neutral condition. It is in ionic condition, CO2 plus condition. Because I am that deficient of electrons, 2 plus, 2 electrons I have deficient. So I need that 2 electrons. So that means my behavior right now, 2 plus electrons, I am in a deficient state. Plus means I have already donated 2 electrons to someone else. Okay, here is sulfate. Okay, no problem. So I need, because due to the deficiency condition, I need 2 electrons. Then I pull 2 electrons towards me. So this is the scenario. Mn plus means if we take the fact of here, copper 2 plus is there, and 2 electrons will be attracted by the copper. Then what will happen? Copper got its 2 electrons. Already copper donated 2 electrons and got 2 electrons. Now the situation is 0. So see, that equation is C. Mn plus n electrons gives rise to M0. Oxidation state is 0. Initially, in the left hand side, oxidation state is N plus, and the right hand side, oxidation state is 0, because acceptance of n number of electrons. Then now they come to the point. The potential difference E for an electrode reaction can be given by Nast equation. This is for the, how many electrons are there? 2 electrons. It here is n number of electrons. Okay. If we take the copper, it is 2 electrons. So now E is equal to E naught cell. What is the formula of that? E is equal to E naught cell minus, see, this is the first formula actually. This is the formula for first. We have discussed about the E is equal to E naught minus 0.0591 divided by N. Then log oxidation by reduction. See, that I am telling about what is this. This is things. Okay. R is equal to, R is here is the real gas constant. There is a value. 8.313. Okay. Is the value of R, real gas. Temperature is standard temperature. Okay. To 295, 98. Okay. Then F is equal to Faraday's constant. This is a constant value. 96494. You can use 494 or 96500. You can use, no problem. Then ln. When ln is converted to log, actually we represent this thing ln, but there is a relationship between ln and log. We know the log calculation, but we don't know the ln calculation. We don't have, right? So ln will convert to the ln. Sorry, ln will convert to the log. 1 ln 1 ln is equal to 2.303 log. That means, so here this is ln will convert it to 2.303 log. That is a constant 2.303 value. So when we put r value, t value, f value, and ln value to log value, okay, 2.303. So altogether, if we calculate, that will be 0.0591 value. Okay, this is the scenario. This is the complete scenario. So you will get 0.0591. So R, T, F, then ln to log is 2.303. So altogether, it will come down. Notch equation will come across that period. So E is equal to inert cell minus 0.0591 divided by N. Here R, T, F, and ln all will be calculated, and the value will be 0.0591. So this is the scenario. Okay. So that's why it will come down here. Here in case of what is that? N value, N is C. That, and the thing is that it will come down where R is equal to real gas constant. I told you. R is equal to gas constant. T is absolute temperature. F is equal to, what I explained, that is written over here. If you will follow the things what I told you, if you will go through that, you will get the point. It is very clear point. See, now the thing is that here R is equal to real gas constant. T is equal to absolute temperature. Temperature I told you 298. F is equal to Faraday constant. You know that 96500 or 96494. You can put N is equal to number of electrons. That is, I told you now. When how much electron is, see, if it is copper is releasing 2 electrons to sulfate ion. So N value is 2. Zinc is accepted 2 electrons. That is 2 electrons are there. Okay, so this is the scenario. So zinc donated that electron and copper is accepted. Along with that sulfate, when current will be, zinc will again will be minus charge will be there. So thing is that that's in that context I just told you. So here that T is equal to that constant depending upon the value. So now the calculation value is E is equal to E naught minus 0.0591. And a ln converted to log 2.303. So it is not mentioned over there. So that is why the value is E naught minus 0.0591 divided by N log 1 by a m n plus. A means concentration of that one. Okay, that is concentration m n plus. What is the concentration of the value, right? So that is the concentration value. So this is C in the last part of that. E is equal to E naught cell minus 0.0591 divided by N log 1 by N plus, because it is accepting. See, you will tell that why it is reciprocal. M n plus, M means concentration, molarity, metal concentration. Metal concentration. M means metal and concentration. Okay. So why it is denominator? Because it accept electron. Which is accept electron, that is reduction. Okay. Loss of electron is oxidation. Gain of electron is reduction. So it accept electron is gain of electron. So reduction. Reduction will always in the denominator part or reciprocal. If it is oxidation, it will part of, because initially in the reaction is given M2 plus Mn plus N electron. So it accept N electron, then oxidation number N plus to 0 changes. Value increases. If value increases, then after plus to 0, value increases. So value increases means that it is accepting 2 electrons, right? So that's why what will happen, this particular things undergoes the reduction. So that will be denominator part, right? So that's why thing is that it is Mn plus concentration. So this is the facts. So in this case, it will come down and calculate the potential of a copper electrode immersed in 0.44 M Cu2 plus CuSO4, right? So this, what will happen here? Molarity. This is the concentration given. Okay, let me to use my whiteboard. Just a second. I'll explain these questions. Just a second, please. Okay. All of you able to see the whiteboard? All of you able to see the whiteboard?
Yes, sir.
That's fine. Let me explain these things. Suppose that here it is given the concentration of copper is given. Suppose 0. What is the amount of copper is given here? Just a second. It's 0.044 m, means molarity. So concentration C, if we take the concentration C, if we concentration, it will take that here is copper. Here is copper sulfate, right? So it will give right Cu2 plus SO4 2 minus, right? Cu2 plus SO4 2 minus. That means copper is in condition of a Cu2 plus. Cu2 plus. So that means how many electron copper is releasing? 2 electrons. So value of N is equal to 2. Value of N is equal to 2. Got the point? Value of N is equal to 2. Okay. Now we'll go. Then we got value of N is equal to 2. Okay. Now the concentration value is 0. It is molarity is given 0.44 m. Whatever the amount, I don't know. Okay. So E cell is equal to, what is the formula? E cell is equal to inert cell minus, just a second. So what is the formula? E cell is equal to inert cell minus 0.0591 divided by n log 1 by reduction. As it is given copper is accepting electrons, so that means it will go on the reduction half. Okay. Now E cell, it is not mentioned. Okay, we were mentioned that is not. E is equal to E naught cell minus 0.0591 divided, what is the n value? 2 log 1 by, here is concentration of that one 0.44. This is the concentration. You have to find out, calculate this one. You have to calculate log value, you have to calculate and you will put the value. So E naught cell if you providing, so then you can also do that. Okay, this is the scenario. By on this process you have to do the calculation. So calculation will be done accordingly. So this is the scenario of calculation. You have to do very simple calculation, but you have to put the formula. Okay. So calculate the potential of a copper electrode emerged in this 0.059. Okay. So you have to find out the calculation of that. Okay. Calculate the potential of zinc electrode emerged in 0.05. Like that copper, even zinc. See, here is zinc. Zinc will, what will do? Zinc will lose the electrons, not accept the electrons. If zinc will lose the electron, it will be in the oxidation half or reduction half. So it will be the upper part. Means that will not reciprocal. 1 by it will not. It will be upper part. Means numerator part, not denominator part. So you have to put that as zinc concentration over there, because zinc is releasing electron. It's oxidation half. Means anode part is there. So that's on the basis of that you have to do the calculation. Try to do the calculation. If any problem will be there, so I'll help you. Okay, someone has some questions. Okay. Okay, Swarnama is that I'll help you sometimes. Sometimes maybe some problem will be there. Okay. So we'll have tomorrow class by 5 p.m. exactly, sir. So you just join, we'll continue. If you have any doubt, anything, anyone has any issues, you can ask me. So I'll close the class.
Sir, E0 value will be supplied during mathematical problem.
Sorry, I didn't get you, Divendu. What did you ask me?
For a particular metal, that is like zinc or copper, the E0 value will be supplied during the
Absolutely.
numerical value.
Absolutely. It is the reduction potential.
Yes, sir.
What I told you, it is the reduction potential.
Standard reduction
Absolutely.
potential.
Yeah, standard electron potential. It is fixed value. It is fixed
Yes.
value. See that if you don't actually practically we have to memorize all the things. Very honestly, I'm telling you, we have to memorize all the things like that. So many common elements are there. Like that, you have to memorize zinc, copper, so many iron, that silver and platinum, hydrogen, chlorine, fluorine. You have to memorize some reduction value. If you memorize, see what is the formula for E0, sir? E0. E0 is E cathode minus E anode. If you don't know the potential value of these two, you cannot place the E0 value.
Yes, sir.
Here,
Yes.
what will happen? Here, what I explained. Did you see that whiteboard? Are you able to see that whiteboard?
Yes, sir. Yes, sir.
Okay. So I just let that E0. As it is copper, we can put the value of copper 0.34.
Okay.
So got the point? I just
Yes,
left that
sir.
on copper. I just left E0 value. E0 minus 0.0592 divided by 2 log 1 by value of concentration. What is given in the
Concentration of
question.
copper.
Yes.
Okay.
But thing is that I know that E0 value of copper is 0.43, right? Volt. You have to put that one. Until unless if you don't know the value of that one, how can you put that value? Yeah, definitely it is. That is
Yes.
but I'll tomorrow I'll share. You can get from any Google source or any book, anything else. It is there, fixed. So it should be.
Sir.
Okay, that's
So
fine.
it should be memorized.
Sorry?
It should be memorized.
Absolutely.
Some common for the common metal.
Common metal. Some common portion you have to memorize. See that when you are practically doing any work, so you can search from anywhere else calculation, right? Because you do have option. But in the exam, if you're sitting and you don't know the value of that one, so it will be. But thing is that you have to memorize some common metals electrode potential value. You have to memorize. If you don't know, you just write down E0. That is all. There is no other option. Okay, that's fine.
Okay.
That's fine. Anything else?
No, sir.
Okay. Thank you very much. So we'll sit tomorrow, sir, by 5 p.m. Right? Thank you very much.
Thank you, sir.